Yes, I'll say my 2 words. So I'm one of the organizers of the program. You can see my biography is on the program. You can see that I came here as something of an amateur. I think I'm the only person who came to this semester from a position of writing crime fiction. But I am a mathematician by training, and I was fascinated by this area. And I came here as something of an amateur, but I'm much less of an amateur now than I was. It's been a privilege, it's been an honor to spend this entire semester thinking about all these important questions that we'll hear about today with people who knew much, much more about it than I do. It's been a real education. And Norman Fenton was something of, I would say, a locomotive really for this program, a driving force. And he's going to be telling us about an overview of all the ideas, the discussions, the research projects that we have spent this semester doing.
Okay, thank you everybody for coming. I'd like to thank the Isaac Newton Institute for enabling us to host what I think has been a really tremendous program, and hopefully people have found it successful. So Layla, David Balding, David Lanyardo, and Richard Gill, the co-organisers. So just a brief history, how do we get to where we were today? Well, the proposal was actually submitted quite a long time ago, 2013, around about sort of shortly after the RVT judgment, which piqued a lot of interest in the use of Bayes and statistics in the law, and I'm delighted that we've got Lord Justice Kitchen. I'm sure we'll talk about that in his presentation this afternoon. So there was, let's say, that interest to, let's say, improve the understanding of use of probability, in particular Bayes, in the law. So they went through various rounds. A revised version was approved in 2013, and a consultation meeting organised by the Turing Gateway took place in London, which, let's say, created an interest amongst not just the forensic and statistics community, but most importantly, the legal community, because ultimately they were the target. They were the people who we particularly wanted to interest in the new ideas that, or extending the ideas and the new ideas that were going to come out of this meeting. And so we've had, so the program's been running from the 21st of July until the 21st December. The first workshop we had basically was looking at the general questions of the use of probability statistical methods in the law. We then had 2 more focus workshops, one which was mainly about Bayesian networks and argumentation in evidence analysis, and then statistical modelling of scientific evidence, where a lot of new exciting research, in particular on DNA evidence, was presented. I was looking back at what we actually said we were going to do, the ambitious aims that we had, and one was to unlock the potential of Bayes and Bayesian networks. This was a particular interest of a number of us, and there's been an enormous amount of work on that subject, and there will be lots of papers and further collaborations, and address challenges offered by new DNA methodologies. That's again, that's certainly a lot of work been going on in that area. But what I'm actually going to focus today, I'm only going to spend 10 minutes, that's all I'm talking for, but is just to summarise what we've been doing with respect to this aim, which actually was stated as the main aim in the proposal, which was to produce a consensual set of public guidelines specifying conditions under which probabilistic techniques can be used in court without the risk of being challenged on appeal. Fairly ambitious, and the idea was essentially to complement and clarify existing guidelines, which are all some fairly recent and very good existing guidelines. And the 3 in particular are the Royal Statistical Society guidelines, of which there are 4 volumes, and I'm very pleased, certainly all the authors of that volume, Colin Aitken, Paul Roberts, Graham Jackson, are here today, and Paul will be talking this afternoon. The EMSI guidelines, which that stands for the European Network of Forensic Science Institutes. Again, members of that, the authors of that report, some of the authors have been active also in this workshop. And then the recent PCAS, that's the President's, whatever it stands for, the President's Council of Advisors on Science and Technology report on the forensic science in criminal courts. So the thing is, these are quite substantial documents, okay? And our aim was not necessarily to do anything radically new, but to basically attempt to come to consensus on what we felt were the key principles to communicate to legal professionals, right? In a way which they could understand and which was very short, right? We sort of set a target of sort of 10 pages maximum. And we've been, you know, a lot of those ideas have come out of work that's been going on here, but we've sort of arrived at this sort of set of principles through a series of discussions in which quite a few people have been involved, and incidentally, if I've missed names out here, I deeply apologise, because there probably were lots of emails with comments that I actually didn't see. So, but this, once we've actually, the next draft will be very widely distributed, so that everyone would be happy to take on the comments and concerns of everybody. And it is a kind of consensus draft at the moment, which means that, yeah, there's views of lots of people. So all the stuff you like came from me, and the stuff you didn't like was from other people. So going through what are these principles? Well, we believe that probability is intrinsic in understanding the impact of evidence, simply because probability is a language of uncertainty, and uncertainty is everywhere in legal reasoning. And associated with each principle, we've come up with some recommendations where the different colours represent the different communities they're targeted to. Now, I'm colourblind, but I think I've got blue for lawyers, green, as I understand, for forensic scientists, and red for statisticians. And incidentally, so for example, the first one, we believe that law schools and forensic courses need to at least teach the basics of statistical and probabilistic thinking. I know that our esteemed Rothschild professor Gert Gigerenzer, I think, will certainly address that point, as well as others. But it's not just one way. You know, statisticians also need to understand the context which probability assessments are made and constrained by the law. This other one, which is actually quite an important point, there's a subtlety here. There's one of the common reasons, the rationales that legal scholars have used for justifying not using probability and Bayes in legal reasoning are a number of so-called paradoxes, like the so-called conjunction paradox, which people like Phil David completely destroyed many years ago, and so these are being completely debunked, totally debunked, and yet we're still seeing papers from legal scholars saying, you've got these paradoxes, this is reason enough why you should never use, why probability and the law don't go together. Okay, so that's where there's an obligation there for the statisticians. And then principle 2, which again is widely discussed in those in all of the guidelines about the need for forensic, given that there's potential errors in any forensic analysis, then those errors should be quantified. So, for example, quantifying false positive, false negative rates, and other types of error rates, etc. The issue of cognitive bias by statisticians and forensic experts has been well recognised. This is something that I think Dave Lanyardo is going to partly address in his talk. These do lead to highly misleading results. The problem is that the standard ways to avoid this, which is normally, you say, a forensic scientist, should be completely detached, should be completely detached from the full context and full information about the case. They should only focus on their particular bit, which in principle sounds great, and that is a way to avoid classic cognitive biases. But as I've been learning from the real forensic scientists, that may actually that may not be a very fruitful approach. It's about getting to the minimal contextual information that's required in order to avoid the bias. There's a very difficult trade-off that needs to be reached there. And then second, there's this idea where you get this other type of bias, and this is something that Richard Gill is going to talk about in his talk, where you get these kind of like statistics-led investigations. So that's something that Richard will address. Now, this sounds like a bit like a statement of the obvious, but again here, there's this issue that there's always people, statisticians like to say, oh, you should use, you've got to use us, if you're dealing with uncertainty and presenting any statistical evidence, because otherwise you'll get it all wrong. But it works kind of like both ways, right? In many cases, if statisticians don't understand the forensic context, they can make they can make assumptions which are either invalid or make their conclusions not particularly interesting. So again, it goes both ways, and of course there are also implications for the legal professionals. The area where graphical models, Bayesian networks come in is is addressing the principle that a lot of evidence, in most cases, evidence consists of multiple independent pieces of information, and the challenge is to combine the uncertainty around that properly, and that's where graphical models, Bayesian networks come in. And while not actually trying to sort of push them too much, we say that anyone involved in evidence analysis at all stages, in particular in the sort of the pre-trial assessment stage, to determine whether you've got enough evidence, let's say, to go forward with the case, especially there, then the recognition that there are tools which do enable you to handle those complex interactions and get the rational results from your uncertainty reasoning do actually exist. One of the most important methods proposed in at least two of the sets of guidelines is a likelihood ratio, which is a very good tool, and it's been the subject of much discussion. So I'm not suggesting there's any there's a great consensus on the subtleties involved in this point. But I think it is recognised that it is a very good tool to use for determining the probative value of evidence, but also it must be used with care in complex situations to avoid misleading conclusions. The idea here is that if you have, let's say, a simple pair of hypotheses to compare, like whether whether person X is the source of this trace or is not the source of this trace, and you've got some particular piece of forensic evidence, then the likelihood ratio works perfectly well there. But when you've got, again, when there are lots of hidden or other hypotheses, and also where the hypotheses, let's say, aren't exhaustive, then there are certain dangers involved if you don't recognise all of the other sort of reasonable alternative hypotheses. Again, in forensic evidence, the notion of a match is highly loaded, and there's lots of misunderstanding. So the need to use that with great care is important. Again, forensic scientists maybe are not necessarily obliged to reduce their presentation of evidence to match non-match. Is quite an important point to make here. This is again something that Marianne Sherps will be addressing in her talk about use of databases. We think it's wrong. It's maybe oversimplistic to think that there's a clear distinction between a good, valid scientific database and one which isn't. Basically, most forensic data, probably all forensic databases, are essentially convenience databases, and they all may have their uses in in particular contexts. And the recommendation is that is that at the very least they should be where it's possible without compromising commercial confidentiality, to make all of those assumptions evident. This is something that Keith Inman, I think, will be addressing in his presentation. In particular, there's a lot of very interesting software evolving for the use of DNA analysis, and the question of the validation of that is one of great concern to the legal community. So we recognise that type of software should be validated, defensible and documented, because otherwise what happens is that you get the results of this software because of different assumptions, which are perfectly reasonable from a statistical perspective, totally reasonable, can lead to very different results. Now, for statisticians, there's no problem with that, but if you're going to present in court, you're going to have a situation where you're presenting in court very different results from essentially the same forensic data, right? Because you've used different tools. That can be that is clearly something that the lawyers are going to pick up on and challenge. So you have to be able to defend that, and there are recommendations for doing so. In a sense, this brings us back to the sort of the RVT conundrum about, what is, the idea that maybe sort of DNA evidence is sort of rigorous, scientifically rigorous, because there's sort of rigorous databases, etc., and other areas of forensic science aren't. Again, we feel there is not. I think it's a misconception to think that there's a clear distinction between objective and subjective assumptions. The key thing is that in every area of evidence presentation, forensic evidence, there are all kinds of subjective assumptions being made. That's inevitable. The requirement is simply that we're saying that you have to make these explicit. That applies to forensic scientists and statisticians, and legal professionals should actually demand that those assumptions are made explicit. And of course, we feel that Bayesian reasoning is a valid method for assessing the weight of evidence and combining evidence. We're not saying it's the only one, but we're happy to hear of other ideas that do it rationally. And there are ways round the traditional objections, some of the traditional objections about the use of prior probabilities, which incidentally may or may not be subjective. You can always use ranges of values and look at sensitivity analysis on key outcomes. And one of the things, there's one plug for a bit of work that one piece of work that we've been involved with here, is that we think that there are now, we think we have got methods for determining almost objective prior probabilities in a range of criminal cases. And finally, again, coming back to the key communication issue, which again, this is, I'm sure that both Paul Roberts and Gert Gigerenzer will be addressing this in their presentations. Clearly, exceptional care is required to communicate statistical analysis. Now, in courts, now, who has, it's for both statisticians and forensic scientists, don't necessarily have the skills to do that. So there are recommendations for how we might improve in doing that. So in summary, the program has brought together, we have tried, we've certainly invited, I believe, everyone who we understood to have been working in the area, be they forensic scientists, statisticians, legal scholars, and actually a very large number of them have come, right? And those who were unable to come, wanted to come. And we tried to really be as inclusive as possible, and I think we were quite successful in that respect. And as we will be reporting, I can't talk about all of this today, but in the report, the final report of the program, you will see that there have been many dozens of new collaborations and some significant breakthroughs, and there are future meetings planned to carry on the work. And we hope that these evolving guidelines that I've presented here, I think that they present an excellent opportunity to make a real impact. Thank you very much.